All right, Unit 1, Lesson 5, Explore continued. We'll see if we can fit the practice on here. I don't know. Let's see how long it takes. All right, so we did abstract. We did part problems, and now we're doing rate problems, which will continue into the next chapter. So we want to make sure we understand how this works. This kind of problem sets up a scenario or a story. Okay, the abstracts, just straight out flat numbers. The parts is like we're talking about objects or consecutive integers. We have this is twice as much as that kind of thing. The rates are a little more of a involved story. You're taking a taxi ride. You're making copies. It's more like an active thing. The rate implied in the problem sometimes has the word per next to it. Miles per hour, gallons per minute, copies, dollars per copy. The rate is a specific amount that changes in the story. It can be decreasing, going down, or negative. It can go increasing, positive, going up. It's the number of something multiplied by this rate. Number of copies, number of minutes in a taxi ride, number of something is multiplied by this rate. Okay, it's so much per hour, that kind of thing. Sometimes the given or starting number and something will rise. Population goes up. As the miles increase, the cost goes up. As the number of copies go up, they're multiplied by this rate. Okay, let's say they can also be decreased by a certain number. Something can go down. Population in this town is dying. It's going down by the rate of whatever. Okay, so it could be a negative number as well as a positive number. So you have the starting number, and then it goes up, or you can just say, I need this many times that. So it's the number of something, maybe a starting amount, maybe an ending amount at the end of the story. The final count or the ending number is determined. Okay. The unknown is somewhere in the problem. It could be the rate. It could be the ending number. It could be the starting number. It could be the number of something. But typically you're looking for the ending number. Remember, the starting number can be given or it's omitted altogether. It just depends on the problem. Okay? So this is another way to say what I just said. You have the end amount, and then you have some sort of rate that is increasing or decreasing, times the number of something plus the start number, if you're given a start number. Okay? How do I know it's a rate? Is there rate wording in the problem? Is something increasing, decreasing, or something per something to figure out if it's a rate problem? Okay. There's a starting amount. Is there a starting amount? Will it go up and down by the rate? Not all of them have a start number, but it could. And the unknown number at the end, or is it the unknown rate or the unknown number of something? And then, is there a variable they want you to use? They want you to use X, they want you to use R, or you're just going to use X because they didn't give you anything. So make sure you're paying attention to use the one that they want you to use. Okay? All right, so example 1. Tyshawn received a paycheck of that for 1 week. He gets this per hour. Per hour, that's the rate right there. Okay? Assuming no taxes were taken out, how many hours did he work? How many hours did he work? That's the number of something. Okay. Write an equation using H. That's the variable they want you to use, and solve. Okay. So some of you know to sit there and do that's this number divided by how many hours he worked, right? Why do I have to set up a big equation if I know that that's going to come up with my 37 hours that he worked? Well, that's great. And I will take that as an equation. But officially, it should look like this. you have a rate times the number of something, okay, equals the ending amount. In this case, we didn't have a start amount, okay? If he was a waiter and he gets, I don't know what it is these days, $5 and something an hour plus tips, he would have a tip number over here. That would be a starting amount, tips plus whatever this turns out to be. But in this case, we didn't, okay? So it's that rate, $12.75 the rate, times the number of hours will give you his final paycheck. So this is the setup for that. You divide to get rid of this part. You end up with a problem that looks like the one you were working on, and your final answer is H equals 37. Okay? Maria ordered some flyers for her company. She budgeted to spend a total of this on the flyers. So that's the N number. Okay, that's how much she wants to spend. There is a fee they charge for the setup. So that's a one-time fee. So that's actually a start fee. Okay, and the rest is for the copies made. So if there's 75 cents per copy, that's the rate, how many copies should she order? I mean, that's not an unreasonable request. If her budget for flyers is $170, she can't go over that. Okay, she called the copy place and they said it was $57.50 for anything to be done. That's the setup they charge for any run for flyers. Okay, and then they charge an additional 75 cents per copy. So how many can she get and not go over her budget? Okay, so this is how you set that up. Here is the rate times the letter, the variable they want us to use. So if it's 75 cents per copy, that's how you do that, 0.75C, right, times, right? Here's the start amount, because that's the start amount for any setup, and together that number can't go over 170, all right? So how does she solve for C, for how many copies she needs? Go ahead and subtract 57.50 from both sides. You get 112.50, and then you want to divide by your 75, which is going to give you 150 copies. She can make 150 copies. 150 times the per rate will give you a number, plus 57 gives you the total of that. Okay? All right, so let's try another one. The amount of rainfall is decreasing. That means the rate's going down. A county in California calculated their annual rainfall is decreasing by this much per year. So that is the rate. Is that inches per year times the number of something. In 2017, the rainfall was this much. How many inches of rain can the county expect in the next year? Write an equation and solve. So the number of something, well, it says 15 inches per year. That's the number of something. Where do I find the number of years? I put number of years. Let's find where that is. Well, let's see. There was a lot of year information. There was 2017. And then how much can they have in 2030, which is 13 years from there. 2030 minus this gives you 13, okay? So 13 is the number of years, number of something, all right? So our equation so far is 0.15 times 13, all right? That's the rate. Do we have a start number? Let's see. Well, in 2017, it was that. That is actually the start number. It was this. This was the amount of rain that they had. And they're trying to see, it's decreasing. Ooh, if it's decreasing, is this supposed to be a positive number over here? This should be a negative number. If it's going down by 0.15 per year, going down per year, Okay, so that should be negative. All right, plus the start amount. So if that's the amount we're starting with and it's going down per year, how much will it be? So in this case, our x, we can put an x there, or you can just leave a blank there, or a question mark there. What is all this here equal to? Well, I need to do this first. Plus the other. I don't think I separated it out. So that's going to come to 23.7 inches per year. So the end number is 23.7. Or x, whatever you want to do. But that's the final answer. You can expect 23.7 inches of rain in 2030 because it went down 0.15 inches per year for 13 years. That's your final answer. Okay? So let's try some of these here. Aaron had 3 times as many. So 3 times as many. That's a part problem. Let's just do that first, and then we'll do the practice on another. That's a part problem, right? We're comparing shirts. He has 3 times as many shirts. So something's going to be x, and something's going to be 3x. Okay. 17-foot board cut into 2 pieces. One's longer than the other piece. This is a part problem. Okay. One is 9 longer, so one's going to be x and one is going to be x plus 9. There's a cost. Flight school portion is more than the ground school, so that's a part. Okay. Something's x and something's 625 more. Second angle of a triangle is 6 times as large as the first, so that's a part problem. There's going to be something that's x, something 6 times x, and something is 20 more. Okay. Perimeter, something more. That's a part. Length is more than the width. Something's x and something's x plus 40. Sum of consecutive numbers, that's also a part problem. Something's x, x plus 1, and x plus 2. 2 more than 3 is the same as 12 less than, okay, that's an abstract. 3 consecutive is a part. I'll do these on the next video. This many hours he makes per hour, that's a rate. 8 times 2 is less than, that's a part. It doesn't look like we're doing many rates here, but we are. I mean, we're doing more rates in the next unit, so that's probably why we're focusing on the other ones we won't be coming back to. All right, I'll do another video on those.